Hello everyone, my name is S.N. Patil. In this video lecture, we will discuss numerical solution of first order ordinary differential equation by Euler's method. Let dy by dx is equal to function of x and y with initial condition. It is also called as an initial value problem. Okay. And x of r is equal to x naught plus rh for r is equal to 1, 2, 3 and so on. Okay. If y is equal to f of x is the exact solution of equation 1, consider Taylor series expansion about x naught is y in bracket x naught plus h. X naught plus h means what? When we put r is equal to 1 here, that is x1, that is x naught plus h. So this is the y at a x1. This is y at a x0, that is y naught. For y at x1 means y at a x0 plus h is equal to y1. Okay. Is equal to y at initial point means x0 plus h. H is difference of x minus x0 is equal to h into y dash. Y dash means dy by dx at a x0 point plus h square upon 2 factorial second order derivative at x0 plus h raised to 3 divided by 3 factorial third order derivative at x0 plus so on. Okay. Now here we neglecting h square and higher order term since h is very small. And we get y x0 plus h is equal to y of x0 plus h y dash. From the second order, we remove this term, means from a square term. Okay. Now here, the value of y at x0 plus h is y1. See here, we already discussed. Is equal to y0 plus h time function at a initial point. Now for x2 is equal to means what? x0 plus 2h. Okay, then the value of x2, y at a x2 is y2. So y2 is equal to y1 plus h time f of x1 comma y1. Now similarly, in general, we can write the value n plus 1 is equal to y at n plus 1 is equal to y suffix n plus h time f of xn comma yn. Okay. Now here we can run the n is equal to 0, 1, 2 and so on. Okay, which gives Euler's formula to find y at x is equal to x1 comma x2 comma dot dot comma xn. Okay, so this is the Euler formula. Y suffix n plus 1 is equal to yn plus h time f of xn comma y, whatever the function is given for the dy by dx. Now let us discuss the example on the Euler's method. Okay. So we consider the initial value problem here. See, the initial value problem is given with the condition y equal to 1 at x is equal to 0 and find y approximately at x is equal to 0.1 in a 5 steps. Okay, using Euler's method. Okay, so here the 5 step, so this 0.1 we divide into 5 parts. That is the one part is, see, 0.1 we divide into a 5 parts. So we get 0.02. That is the value of x1. Here the value of the x1 we start from 0.02. x2 is equal to 0.04. X3 is equal to 0.06. X4 is equal to 0.08, and the fifth steps is 0.1. Okay, that is 0.10 means 0.1. Now we have the differential equation dy by dx is equal to y minus x divided by y plus x. Okay. Now the right hand side term is a function, that is f of xy is equal to y minus x divided by y plus x. Okay. Say equation number 1. Now here with initial condition, see y x naught is equal to y naught. So here y of x naught is here y in bracket, this is the x naught, that is 0 is equal to 1. It means x naught is equal to 0 and y naught is equal to 1. Okay. Now by Euler's method, we write the first general formula. By Euler's method, y suffix n plus 1 is equal to y suffix n plus h time. H means difference. Okay. F of xn comma y suffix n. X suffix n comma y suffix n, and we put n is equal to, see we have the y naught here. Okay, so that we put n is equal to 0, 1, 2, 3 and 4. Okay, because we want the 5 steps. Now put n is equal to 0 here. N is equal to 0, that is y1 is equal to y naught plus h time f of x naught, n is 0 comma y naught. Okay, now y naught is given, y naught is 1 plus h is difference. So here this is the, see if we calculate the difference, x2 minus x1 or x3 minus x1, we get throughout the difference is 0.02. Okay, and function, now function is, see this is the function, it can be written as, now I am writing same step again, y naught plus h time function is this in terms of y naught and x naught, that is y minus x divided by y plus x. So here we write suffix and suffix. Okay, y naught is 1 minus x naught is 0 divided by y naught is 1 plus 0. So here 1 minus 0 and divided by 1 plus 0, that is 1 upon 1 is 1 into 0.02, so that we get the value of the y1. Value of y1 is 1 plus 0.02. So it is 1 plus 0.02, that is 1.02. This is the value of y1. Okay, y1 means what? See here in a first slide we discussed y1 means at x naught plus h. Okay, the x naught is 0 and h is 0.02. Okay, so that the x1 here, this y1 means what? Y in bracket x1 is 0.02. This is y1. Okay, is 1.02. It means the value of x1 is 0.02. Now next iteration, put n is equal to 1 year. Suppose this is equation number 2. Put n is equal to 1. Then y suffix 2 is equal to y1 plus h time function f of x1 comma y1. Okay. So now we have the requirement of the formula is y1 x1. We have the y1 x1. Okay. Now y2 is equal to y1. Y1 we have calculated 1.02 plus h. H is 0.02, and the function, see, I'm writing function here, y upon x divided by y plus x, okay, is equal to 1.02 plus 0.02. So here y minus x and divided by y plus x. See, this is the x1 comma y1 point. So here suffix 1, suffix 1, suffix 1, suffix 1. Now the value of y1 is 1.02. Value of the x1 is 0.02 divided by 1.02 plus 0.02. Okay. Now calculate this value is equal to y2 is equal to, we get 1.0392. Okay. Now this y2 means what? At x2, and the x2 is 0.04. Okay. Now next iteration, put n is equal to 2 in equation 2. So y3 is equal to y2 plus h time f of x2 comma y2 is equal to y2 plus h time in bracket. What is the function from 1? Y minus x divided by y plus x. Okay, but at suffix 2, x at suffix 2 and y at suffix 2, that is right, suffix 2 here, 2 here, 2 here. Okay, is equal to, the value of the y2 is 1.0392 plus h is 0.02. Now the y2 is 1.0392 plus, sorry, minus here, minus 0. Here minus 0.04 divided by same value 1.0392 plus 0.04. Okay, now simplify this value through calci. In calci you can type the direct program y suffix 2 plus in calci you can type the program y plus h in bracket y minus x and y plus x and press calci. You just enter the value. So here we get y3 is equal to just wait, 1.0577. Okay, now this is the y3 at x3. X3 means 0.06. Okay, now we got the y3 and x3. Now the next iteration, put n is equal to 3 in equation 2. So we get y4 is equal to y3 plus h time f of x3 comma y3. Okay, is equal to y3 plus h. What is the function? Y minus x divided by y plus x. Okay, and suffix 3. Yeah. Okay, now substitute the value. The y3 is 1.0577 plus h 0.02 in bracket. The value of the y3 is 1.0577 minus 0.06. Now same value, only addition is there. 1.0577 plus 0.06. We get y4 is equal to y suffix 4 is equal to 1.0738. So this is the y4 at a x4. So x4 is equal to 0.08. Now the last step, put n is equal to 4 in equation number 2. Okay, see, this is the equation number 2. We put n equal to 4 here. This is the last step. It requires the 5. Okay, so that it is the last. That is y suffix 5 is equal to y suffix 4 h time function of x4 comma y4, okay, is equal to y suffix 4 plus h. The value of f of xy is y minus x and divided by y plus x. But at x4, y4, so that we write suffix 4. Okay. Now substitute the value. The value of the y4, we have calculated 1.0738 plus value of the h is 0.02. Now y4 is 1.0738 minus 0.08. Same value in denominator, only addition. 1.0738 plus 0.08. Okay, so we get y5 at 1.0910. Okay, now this is the value at x5. Okay, x5 means what? Increment in a x4 at a 0.02. So we get 0.1 here. Okay, so this is the y at a 0.1. Now y5, it can be also written as 0.1 is equal to 1.0910. Okay, now next problem. Given initial value problem, dy by dx is equal to minus y with the condition y is equal to 1 at x equal to 0. Okay, find y at a 0.04 with h is 0.01. Means in every iteration add the 0.01. Okay, means what? Suppose we start from the x naught. X naught is, this is the x naught. X naught is 0. Then x1. X1 is x naught plus h. Okay, so x naught is 0. So x1 is 0.01. Now x2. X2 is x naught plus 2h. Means h plus h. Okay, so this is what? 0.02. X3 is, now it can be written as x naught plus 3h. That is 0.03. And x4 is last 0.04 in this way. Okay. Now we have the equation. See, there are two questions. Find the numerical value at y equal to 0.04. Okay, this is the first question. And the second question is compare the result with exact solution. So we find the solution using traditional method. Okay, and compare with the numerical result, numerical solution. Okay, now let dy by dx is equal to minus y. From the definition, dy by dx means function f of xy. So f of xy is equal to minus y. Say equation number 1. So we require the f of xy for Euler's formula. So here f of xy is minus y. Okay. Now with initial condition is y is equal to 1 at x equal to 0. It means what? X naught is 0, okay, and y naught is 1. Okay, this is also written as y of x naught is equal to y naught. That is y of 0 is equal to 1. Now by Euler's method, now I'm going to write general formula. Y suffix n plus 1 is equal to y suffix n plus h time f of x comma y. Okay, suffix n and suffix n. Say equation number 2, and we put here n is equal to 0, 1, 2, and 3. There are 4 iterations. Now put n equal to 0. Put n is equal to 0 in equation 2. That is y suffix 1 is equal to y naught plus h time f of x naught. This is x suffix n and y suffix n. Here 0. Okay. The value of the y naught is 1 plus value of h. H means increment in every iteration, that is, which is constant 0.01. Okay. And the function is minus y. So just write minus y and suffix naught. Okay. So we get here, y1 is equal to y naught is 1 plus 0.01 into y naught is 1 minus 1. So y1 is equal to, now simplify this, 1 minus, see, minus 1 is multiplied here, 1 minus 0.01, that is 0.99. Okay, so this is the y1 at x1. So x1 is 0.01. So this data is useful for the second iteration. Now put n equal to 1 here. That is y suffix 2 is equal to y1 plus h time function. So here I am direct write the function is minus y. Okay. So here y1 is 0.99 plus h is 0.01 and minus y1 0.99. Okay, we get y2 is equal to 0.9801. We get y2 is equal to 0.9801. So this is the value at x2. x2 means in x1 we add the plus h, that is 0.02. Okay, now next x3, sorry, y3. Put n is equal to 2. So we get y3 is equal to y2 plus h, and the value of the function is minus y. So here minus y and suffix 2 is equal to y2 is 0.9801 plus h is 0.01 and minus 0.9801. Simplify this, then we get y3 is equal to 0.9703. 9703. Okay, at x3. x3 is, add here h distance 0.03. Okay, now last iteration. The last iteration is put n is equal to 3 in equation number 2. So y4 is equal to y3 plus h and function at x3 y3 means minus y suffix 3 is equal to, that is the value of the y3 is 0.9703 plus 0.01 value of h and minus 0.9703. So we get y4 is equal to 0.960. Here we round up here, that is the 6. So this is the value at x4. x4 is 0.04. Okay, so this is the numerical value, means y at a 0.04 is equal to 0.9606. Okay, now let us find the exact solution. For exact solution, now consider, see, this is equation number 3. We have dy by dx is equal to minus y. Use variable separable method. Dy upon y is equal to dx is multiplied here minus dx. Now integration, then we get log of y is equal to minus x is equal to plus integration constant log of c. Now it can be also written as log of y is equal to minus x. It can be written as log of e raised to minus x. We know log of e raised to function is function. Okay, plus log of c, that is log of y is equal to, apply log of a plus log of b property of logarithmic, log of e raised to minus x c, taking antilog both sides, then we get y is equal to e raised to minus x c. So this is the general solution. Okay, say equation number 4, general solution. Okay, now put x is equal to, see here, we substitute x is equal to 0 here. First we calculate the c value, put x is equal to 0 in equation 4, that is y of 0 is equal to e raised to 0 into c. E raised to 0 is 1 and c, and y at 0 is 1. Okay, so that we get c is equal to 1. So we get a particular solution. Put c equal to 1 here. We get y is equal to simply e raised to minus x. So this is the particular solution. Equation 4 is general solution and 5th is particular solution. Okay, now put x is equal to here. Put x is equal to 0.04 in equation 5. That is y at a 0.04 means e raised to minus 0.04. We get 0.9608, and now we have the value is 0.9606 and here 0.9608. Okay, so this is the solution by exact method, yeah, traditional method. Okay, see, up to the 3 decimal places the solution is as compared to same, but at the 4 decimal the error is there. Okay, thank you for watching.